Welcome. In our previous lesson, we have looked at graphing the solutions to inequalities. My name is Nana Yawedu, and you can call me Senana. Remember to like this video, share this video, subscribe to my YouTube channel, and don't forget to click on the notification bell so that you can get all videos on time. Now, in this lesson, we want to consider some type of function. We want to consider polynomial functions. We want to look at what polynomial functions are and what they mean when it comes to their use in our daily lives. Now, let's consider the polynomial functions. So when we consider polynomial functions, we see polynomial functions as comprising various combinations, right, such as constants. When we talk about constants, we are looking at things like 3. 3 can be a constant. We can have a value like 6, -4, right, half. So these are constants. And normally we represent constants by variables like a, b, c, and the likes, right? And then we also have variables. So it could be in x, right? Or it could also be in m. It could be in y, right? So it combines these things, right, with their exponents, and then it's of the form. So the general form of a polynomial function we say is px of n. We know that the function can be written, so this function is in terms of x. So px of n, right, is equal to, so the first one is a, which is a constant, multiplied by x, which is a variable, raised to the power n, where n is a non-negative or a positive integer, right? So n represents the power, right? So when we move on, the b now is also a constant. We have x, and then n reduces by 1, so it becomes n minus 1. And then we'll move on to c, right? We have x, n reduces by 1 again, right? So we have n minus 2. And then it moves on to d, we have x, then we have n minus 3, right? Until you could go on to get a constant value, right? So this is a general form of finding a polynomial function. Now, there are different types of polynomial functions depending on what n is. So, for instance, if n is equal to 0, we see that the f of x, which is a function, is a constant function. So we get f of x to be equal to c. So for instance, if n is equal to 0, we have f of x to be equal to, let's say, ax raised to the power 0. We know x raised to the power 0 is equal to 1, right? So we are going to have f of x is equal to a, right? So c or a can be any function. So we have f of x to be equal to, let's say, half. This is a constant function. Or f of x is equal to 4. This is a constant function, right? So these are constant functions. And then we also have a linear function. When n is equal to 1, then it means that we will have our f of x to be ax plus b. So for instance, we have f of x to be equal to 3x plus 2. We know that this is a linear function, right? It's a linear function because n is equal to 1. So when we look at the general form, we can have f of x to be equal to ax, right, raised to the power 1, plus bx raised to the power, right, 1 minus 1. Where in this case, we have f of x to be equal to ax raised to the power 1, bx raised to the power 1 minus 1 will give us 0. So we are going to get plus b. So it means that our f of x is going to be equal to ax plus b, right? And this is a typical example of that. We can also have another function, f of x to be equal to x minus 2. This is also a linear function. And then we could also have a quadratic function, which we already know. Once we have the function having the power n to be equal to 2, then f of x becomes equal to as squared plus bx plus c. So for instance, we can have f of x to be equal to x squared plus 3x plus 5, which is a quadratic function, right? Or g of x is equal to x squared minus 1, right? This is also a quadratic function. So far as the highest power of the x is 2, then it means that we have a quadratic function. We can also have a cubic function, and with cubic function, n is equal to 3. So when n is equal to 3, we get a function f of x to be equal to as cubed plus bs squared plus cs plus d. So for instance, we can have f of x to be equal to 4x cubed plus 3x squared plus 2x plus 1, right? This is a cubic function. Or we could also have g of x to be equal to x cubed minus 2x squared plus 6. Once the highest power of the x is 3, then it means that we have a cubic function, right? When n is equal to 4, we have a quadratic function. So a quadratic function is as raised to the power 4 plus bs cubed plus cs squared plus ds plus e. So for instance, we can have f of x to be equal to 16x raised to the power 4 minus 4x cubed plus 6x squared minus 3x plus 2, right? And this is basically a quadratic function because the highest power of the x is 4. We can also have g of x to be equal to x raised to the power 4 minus 1. This is also a quadratic function. So far as the highest power of the x is 4, then irrespective of the fact that there are other values are not there, it could represent the fact that those ones are 0 raised to the power x, 0x raised to the power cube, right? Or 0x raised to the power squared. So this is also a quadratic function. And then we can also have a quintic function. That is when n is equal to 5, or where n is raised to the power 5. We have the function f of x to be as raised to the power 5 plus bs raised to the power 4 plus cs cubed plus ds squared plus es plus f. So for instance, we can have g of x to be equal to 4x raised to the power 5 minus x raised to the power 4 plus 16. And this is a quintic function because the highest power of the x is 5. Or we can also have h of x to be equal to x raised to the power 5 minus 1. And this is also a quintic function. So in this lesson, basically we have gone through looking at polynomial functions, and we have looked at several examples of polynomial functions, which includes the constant, which includes the linear function, the quadratic function, the cubic function, the quadratic function, and then the quintic function. In our next lesson, we want to consider operations on polynomial functions. Remember to like this video, share this video, and subscribe to my YouTube channel. See you in the next lesson.